So here we're given our matrix A and we're asked 3 questions about it. So the first one is to find the determinant, the second is to state why it has an inverse, and the third is to actually find that inverse using the Gaussian elimination technique. So let's start by doing the determinant of our matrix A. So in order to do this, we need to pick either a row or a column to expand around, and usually you want to pick one that's got a lot of zeros in it to make your life a bit easier. So that means if I look at this matrix, the only one that has zeros in it is the second row. So that's what I'm going to pick to do my expansion about. So let me just write out our matrix. Cool. So if I'm going to expand around our second row here, we know that the top left element is treated as like a positive when we do the determinant, and then it alternates as we move away from it. So that means that this one here would be a negative. We alternate again as we move across, so negative, this would be positive, that one, and then the 0 would be back to negative. Alright, so the first thing that we pick out if we're using the second row is our 0 element, and it would be like negative 0, and we would multiply by the determinant of what's left over, but since it's 0, there's not much point. So let's move on to the next element, which is going to be positive, and it's a 1, and we need to multiply by the determinant of what's left over when we cover over the row and the column. So if we ignore these for a moment, okay, we've covered over them. All that we're left with is 1, negative 1, negative 1, 2. Okay. And then the final element that we have is 0, and it would be negative. Again, since it's 0, there's not much point writing in the rest of the determinant calculation because it's just going to drop to 0 anyway. Alright, so now we just need to expand out the determinant of a 2 by 2 matrix, and that's really easy because it's that AD minus BC equation. So 1 stays out the front, AD is going to be 1 times 2 minus BD, so that's going to be the negative 1 times negative 1. So in here we're going to get 2, and then we've got negative 1 times negative 1, which is positive 1, but then it's minused away, so minus positive 1. So we end up with an answer of 1 for the determinant of our matrix. So that answers the first part here. So next up, we need to state why our matrix A has an inverse. And there's 2 kind of requirements for an inverse. So an inverse exists if, got 2 things. The first one is you have a square matrix. Okay, so if we look at our matrix A, it is indeed a square matrix. It's a 3 by 3 square. Okay, so we've definitely got that one. And the second requirement is that the determinant of our matrix, so put in A here, does not equal 0. Okay, anything other than 0, then it's good. So we've got 1 here, so that means that we've addressed that requirement as well. So since we've met both of these criteria, then our matrix A has an inverse. So maybe I will conclude this with criteria met for A. Cool. Alright, so the last little bit is where probably the bulk of the working is. So we need to find the inverse of A using Gaussian elimination. So in order to do that, we need to set up our matrix that we're going to perform operations on. So for Gaussian elimination, we set it up with this kind of look. So we have the matrix A on the left, and I is the identity matrix on the right. So let's pop it in. So 1, 2, negative 1, 0, 1, 0, and negative 1, 1, 2. And our identity matrix, remember that's where we have the 1s on the main diagonal and 0s everywhere else to fill it out. Cool, so that's what I've got there. So now all we need to do is perform our row operations to get the left-hand side looking like this identity matrix. And then whatever falls out on the right-hand side becomes our inverse. Now I'm going to follow the pattern where I move around in this shape in order to solve for my inverse. Okay, there are other ways to do it, but the way that I'm going to do it now is one that is always going to work. So sometimes you might be able to shortcut it using a different method, but yeah, I'm just going to go with this generic kind of one. So if we're working in this pattern, the first one that we look at is top left, and what we want this to be is a 1. Remember, we're going for our identity matrix. That looks like this. Okay, so top left needs to be a 1, and we've got that. The second one here that I'm working on is a 0, and again, it's already looking like what it needs to be, so we don't need to do any operation on it. So if we jump down to the next one though, at the bottom here, it's a -1, and we want it to be a 0. Okay, it's a bit messy, but yeah, we want it to be a 0. So we're going to need to perform an operation on it. So what I would suggest is operating on row 3. If I add on row 1 to row 3, I should get -1 plus 1, and that goes to 0, which is what I'm looking for. So let's do that. All right, so that means that the first row, isn't changing, and neither is the second row. So I've just copied those out. But the third row is changing now. So -1 plus 1 gives us 0. 1 plus 2 gives us 3. 2, this is plus -1. It's going to take us to 1. 0 plus 1 is 1. 0 plus 0 is 0. And 1 plus 0 is 1. Alright, so this one's fixed up. So I'm going to move on to this one. And we want it to be a 0. Okay, so we have kind of two options on how we can get this to be a 0. We could either add some multiple of row 2, or we could add some multiple of row 1. Now I would suggest using row 2 here. That's because we're going to end up with 0 plus anything times 0 is 0. So this cell that we just fixed up isn't going to change. However, if you use row 1 in your operation, you're going to get 0 plus or minus something times 1. So it is going to change, and then you're going to have to go back and fix it again. Okay, so based on that, I'm going to use row 2 in our operation. Oh, that's meant to say R3. So using R2, if I do my row 3 and I take away 3 of R2, that should get me 3 minus 3 times 1, which goes to 0. So that's what I'm looking for. So again, the first 2 rows are not changing. So I'm just going to copy them out. And now this third row, we're going to change. So we've got 0 minus 3 times 0, which leaves us with 0. 3 minus 3 times 1, which takes us to 0. We've got 1 minus 3 times 0, which should leave us with 1. We've got 1 minus 3 times 0 again, which should leave us with 1. We've got 0 minus 1 times 3. That should take us to -3. And we've got 1 minus 3 times 0, which should just leave us with 1. Awesome. So now this one is fixed. So moving on to our next one, we have a 1 in here. Now that's actually what we were looking for if we go back and look at our reference. We want a 1 in the bottom right corner, so that one's good. Don't need to do anything. So next, if I move up to this one here, we've got a 0. Again, that's what I'm already looking for in that cell, so I don't need to do anything with it. So jumping up again, get this top right, we want this to be a 0. So we are going to have to perform some operation to get there. So what I would suggest this time is if I do this top row plus the bottom row, -1 plus 1 takes me to 0. So I should be able to get that back to where I want it. So we're operating on row 1, we want row 1 plus row 3. So let's go down and perform that. So 1 plus 0 gives us 1, 2 plus 0 gives us 2, -1 plus 1 gives us 0. We've got 1 plus 1, which is 2, 0 plus -3, which is -3, and 0 plus 1, which is 1. So everything else remains the same because we haven't operated on it. Make this a bit neater. Cool. All right, so moving back here, we have a 2. So we want to get this 2 to be a 0, that's the top middle here. So what I would suggest for this one, we're going to operate on row 1, and if we do row 1 minus 2 row 2, we should be able to get this to go to 0. Alright, so row 1 minus 2 times 0, so we're going to get, this just ends up being 1 again. So 2 minus 2 times 1, that takes us to 0. 0 minus 2 times 0 is 0. 2 minus 2 times 0 is 2. Negative 3 minus 2 times 1, that's going to take us to negative 5. 1 minus 2 times 0, that's going to leave us with 1. Again, everything else just remains the same because we didn't operate on it. Cool. Alright, so now looking at our last element, we can see that this has ended up becoming a 1. And of course that is what we were looking for it. So now the entire left-hand side here, we can say that that is the identity matrix. And that means that the right-hand side is now the inverse of A matrix. So we can conclude our final answer, which was what is A inverse, and we just need to copy this out. So 2, negative 5, 1, 0, 1, 0, 1, negative 3, 1. And that there is the end of the question. So that's all there is for this video.